My name is Leonie. I am an accessibility engineer for a company called the Paciello Group in the United States, and I'm also the accessibility lead for the UK government, working on the GovUK platform. I also work with lots of other people at the W3C on specifications like HTML5, SVG, and ARIA. Today, I would like to talk to you about accessibility mechanics, how the HTML that you write works in the browser to make accessible information available to people like me who are blind and use technologies called screen readers. I'd also like to talk about ARIA, the Accessible Rich Internet Applications specification, and how you can use ARIA to fix some accessibility problems for screen reader users. So HTML mechanics. When you write HTML code, you may not know it, but a lot of accessibility is done for you by the browser. When you choose to use an HTML element, it has a role, and its role tells the browser what that element does. So for example, if you use the image element, the browser knows that it's a graphic, and a browser will tell an assistive technology like a screen reader that they're dealing with a graphic. So a screen reader coming across this piece of code would say graphic Chimukas tequila. So as a screen reader user, I know it's a graphic, it's a picture on the page, and I have a description of it because of the alt text. Main element, the HTML5 main element, is another example. The browser knows that the role of this element is to represent the main content area of the page. And again, the browser tells my screen reader that's what this element represents. Main is slightly different from other elements because it's what we call a landmark element. Not only does my screen reader know that it represents the main content area of the page, it also can navigate by landmark elements. There are others. Main, nav, article, aside, header, and footer are all landmark elements. So my screen reader knows what each of those elements means, but it can also navigate. I have a shortcut in my screen reader that lets me move from one landmark on the page to the next. And when I reach a new landmark, my screen reader tells me what it is. Span and div elements are different. They don't have roles. When a browser sees content in a span or a div element, it just acknowledges the content of the spans. Span and div themselves don't have a role. So my screen reader, if it came across the code on screen now, would just read the content of the span, this is text, or the content of the div, so is this. There'd be no other information available about this particular content. And that's really important when you think about developing custom widgets that are based on span and div elements. The browser also makes information about the name of elements available to screen readers and other assistive technologies. For example, when we use an anchor element, the text inside the element opening and closing tags gives the link its accessible name. So when a screen reader comes across this link, it'll tell me it's a link, it recognizes the role, and then it'll say Tink UK, and that's its accessible name. An accessible name is like a person's name. It's just a way of differentiating one link on the page from any other link on the page. And accessible names can come not just from the content of an element, but they can also come from attributes, like the alt attribute that provides a text description for an image. The thing that differentiates this image from any other image on the same page is its alt text. And as I said before, my screen reader will tell me graphic Chimukas tequila. And in this case, Chimukas tequila is the name for this graphic. An accessible name can also come from another element that's associated with the first element. So when you use label for an input, the text of the label becomes the accessible name for the form field. And when a screen reader focuses on this form field, it'll hear that it's an edit field because you can enter text into it, and it'll also hear the text of the label announced automatically. The browser also tells screen readers something about the state of different elements. So when you use the checked state on an input element, that information is made available to my screen reader. So when I focus on this checkbox, I'll be told it's a checkbox, it's checked, and that it has an accessible name provided by the label. There's also a required state. And again, if you use this, in this case on a select, my screen reader will tell me what type of form field I'm dealing with, a combo box, and that it's required. In other words, that I must enter some information into this field before I can continue with the form. The last thing the browser does for you when you use HTML is handle keyboard focus. Lots of people don't use a mouse at all. Lots of people use a keyboard as well as a mouse. And the browser will make sure that when you use different elements, you can use them with a keyboard or with a mouse. So if you use an anchor element with an href attribute, the browser will automatically let a keyboard user move focus to it. So if you use the tab key to move through content on the page, you'll be able to move focus using the tab key to a link. If you use a button element, the same thing will happen. The difference between the two is that the browser will let you activate or use a link using the enter key, and it'll let you use the button element using either space or enter keys. But you don't have to do anything to make this happen. The browser does it all for you just because you've used HTML. So how do we get this information? Well, the screen readers query the information from the browser using accessibility APIs. And there are accessibility APIs on every platform. On Windows, we have MSAA, UI Automation, iAccessible2. iAccessible2 is also available on Linux. On Mac OS X, there's NS Accessibility Protocol, and there are also APIs available for Android and iOS. So what happens is when a screen reader comes across a control, say in the operating system, the checkbox on screen is from Windows 10 in the control panel, they can query the control using the accessibility API for that platform. And when they do, they're told that its role is a checkbox, that its accessible name is bold, because that's what the checkbox enables you to choose, and that its state is focused, focusable, and checked. The interesting thing is that if you use HTML to create a checkbox, exactly the same information is available to a screen reader querying the control using the accessibility API for Windows. It says it's a checkbox, that its accessible name is bold, and that it's focused, focusable, and checked. And that's the great thing about the accessibility APIs, is from my point of view, whether I look at a checkbox in the operating system, a checkbox in an application, like my browser or an email client, or a checkbox that's been coded with HTML, the information is exactly the same. So there's a very consistent experience. There is a document created by the W3C that maps these relationships. So when we say that a checkbox in the operating system is the same as a checkbox on a web page, this document from the W3C maps that relationship. And if you're interested to find out what the roles of different HTML elements are, it's worth looking at this specification. So how does the browser make all this information available? We have the API to query that information, but how does the browser actually expose it to assistive technologies? When you write a web page, the browser will create a document object model, a DOM tree. It's a representation of all the content on the page in a hierarchical form. And you can use JavaScript to access it, change it, update it, or do all sorts of different things to it. The browser takes some of the information from the DOM and creates a separate tree called the accessibility tree. And this information is just for screen readers and other assistive technologies. It's very similar to the DOM, but it is completely separate, and it just has information that's useful for accessibility, nothing else. So how do we access the information in the accessibility tree using the accessibility APIs? Well, we can't use JavaScript, unfortunately. There's no way as developers for us to use JavaScript to query the information in the accessibility tree or query the accessibility API directly. Work is planned on a specification at the W3C that will try to find a way to make JavaScript access to the APIs and the accessibility tree possible. There's a new working group coming at the W3C called Web Platforms, and this will be one of the projects that that working group will be looking at. In the meantime, we can use ARIA to change the information the browser makes available in the accessibility tree. We can use JavaScript to create and add and change the ARIA, but only the ARIA itself makes any difference to the information that's made available to a screen reader. So what does ARIA do? Well, it's a specification from the W3C. 1.0 came out last year, but we've been using it for a lot longer than that, and we're working on version 1.1. In 1.0, there are more than 30 roles described. There are roles for all sorts of different things, like sliders, checkboxes, dialogues, toolbars, menu items, lots of different things that we build every day on the web. And what you can do is choose to apply one of those roles manually to your code. And we'll see how that works in practice in a minute with a quick example of an alert role. You remember I said that a div had no role of its own. The browser doesn't really recognize a div as having any particular purpose. But if we use a div to represent a notification, an important message on the screen that we want people to be aware of, we need to do something to create the same experience for screen reader users. This message may appear visually on screen and catch someone's attention if they're sighted, but for me as a screen reader user, there's nothing to tell me that this message is important. If we use the role attribute to give this div a role of alert, that changes the experience for me. When this message appears on screen now, my screen reader will automatically read it. The alert role says, hey, you need to treat this content as important. And screen readers, you need to tell your user what the message is inside this div, because you now need to treat it like an alert, which is more important. Another role is note. Again, if you have a div that just contains some text, some content that's related to the main content of the page, but perhaps visually styled to look a little bit different because it's just a note attached to it, you can add a role of note, and this then changes the information that's available to the screen reader. In this case, it will just say, this is a note. Simple as that. So now when I listen to content and I come across this, it will say, note, loves drinking, dancing, and drinking tequila, which is a pretty important note. Something else happens in the ARIA specification. Its states are possible to apply, and there are 9 different states in the ARIA specification. ARIA checked, ARIA pressed. All these attributes have ARIA and then a dash before them, so they're easy to tell apart from HTML elements. For example, on a button, we can use ARIA-pressed, and you use this for a toggle button, like a mute button on a media player. When someone presses it, visually, the button will look like it's been pressed, but that's not communicated to someone who can't see the page. So we used ARIA-pressed, and we set it to true, and a screen reader will now say that this button has been pressed. Or if we hit the button again and you change its value to false, the attribute will say that it's not pressed, but just let the screen reader user know that this is a toggle button. ARIA invalid, ARIA-invalid is another attribute, this time one we use on a form. For example, if we have an HTML email input and someone enters some information into that field that isn't an email address, we can set ARIA-invalid to true, and that will tell the screen reader that the information they've entered in this particular field isn't correct, it isn't what was expected. And again, you team this up with visual styling that lets sighted people know that they've made an error or the information isn't correct in the field. There are also properties in the ARIA specification. Things like ARIA label, ARIA labeled by, ARIA described by, ARIA has pop-up, and more than 20 different properties that you can apply to elements in your HTML. We can use ARIA-label to give an element an accessible name. I mentioned earlier that nav was one of the elements that's a landmark element in HTML5, so a screen reader user can navigate to it using a shortcut key. If you just use the nav element, when a screen reader gets to it, they will hear something like navigation region, which is fine, but if you have lots of different navigations on the page, it's useful to know the difference between one and another. So again, we give it an accessible name. And in this case, we've used ARIA label and given it an accessible name of website. So now, when a screen reader gets to this particular nav element, it will hear website navigation region. And of course, you could change website for page navigation, search navigation, or whatever would be suitable to the design and content of the page. We can use another property, ARIA-described by, to give an element an accessible description. So an accessible name tells one element of its kind apart from another. An accessible description provides more information to help someone use a control more easily. So in this case, the form field is for date of birth. That's its accessible name, and that's the first thing the screen reader announces. But there's more important information about the format of the date that needs to be told to users. And we use ARIA-described by to attach that information to the form field. So now the screen reader will automatically announce that helpful information just after the accessible name is announced itself. ARIA has pop-up is another property. If you have a button that produces a menu on screen when you use the button, you can use ARIA-has pop-up set to true, and that means when a screen reader user focuses on the button, they'll be told has pop-up. So they know that when they activate the button, a menu will appear on screen. And all of these attributes are best used when they duplicate image that's available to a sighted person, information. If you can see how something works or see what's expected of you in a form or an interaction or a control, ARIA is one way of making the same information available to someone who can't see a page. There are some things to be aware of about ARIA, though. It doesn't change the DOM. What the browser does when it converts your HTML into the DOM tree remains exactly the same. When you use ARIA, it only changes the information in the accessibility tree. So ARIA has no effect on anything except for screen readers and a couple of other types of assistive technology, speech recognition tools most notably. So it's very much focused on screen reader users. In time, it's hoped that that will change because ARIA has the potential to be a useful tool for lots more people who benefit from accessibility. But right now, it's important to be aware that it's pretty much just for screen reader users. And that leads to another problem. If you're using ARIA as you develop, you can't see what it does on the screen. There is no visual representation of ARIA. So if you add ARIA, it's really difficult for you as developers to know whether you've got the right role, you've added the right property, or put something into the right state. There is a tool called Visual ARIA by Brian Garaventa that's just been released. And it's a bookmarklet that uses CSS to let you see how ARIA is being used in your code. So if you develop for accessibility using ARIA, I recommend that you use this bookmarklet because it will make life a lot easier for you as you develop. So let's bring all of this together into something that feels a little bit more real. We're going to create a disclosure widget, a button that when you press it, shows some content on the page, and when you press the button again, it hides that content away. And we're going to start from the most basic of HTML, a span for the control and a div for the content. Now, you'll remember that these elements have no roles of their own, so the information here will just be treated as plain text by assistive technologies. If we give it some CSS and JavaScript, we can create a disclosure widget that will work really well with a mouse. And when you use a mouse, your experience will probably be something like this. It all pretty much works as expected. You use your mouse, you click on the button, the content appears, you read it, you can close it again. If you use a keyboard, this is what happens. Absolutely nothing at all. You can't focus a keyboard on a span. The browser doesn't recognize span as something that can be interacted with, so it doesn't provide any of that keyboard interaction that is really needed. So this is one of the areas why it's good to use HTML, because the browser does a lot of that work for you. If I can swap my audio over, I will now endeavor to show you what happens when you use this with a screen reader. Because you can, with a screen reader, focus sometimes on things that you can't get to when you use a keyboard without a screen reader. What happens when you do is this.
Tequila.
That's it. You just hear the one word that's inside the span, because the screen reader sees the span, says, hey, that's nothing important. I'll just tell you about the content that's inside the span. So I just get that one word, tequila. The problem is, I don't know that I can press that thing. There's nothing that says it's a button, a link, or something I can interact with. So if I were using this widget, well, I wouldn't use this widget because simply I wouldn't know that it's there. So we can do some things with ARIA to change all of these things. We can use the role attribute to tell screen readers that this span is actually a button. So now when a screen reader encounters this control, it will say tequila button. So we're starting to build up that information. Again, on the span, we can add the tab index attribute, and we can give it a value of 0. What this does is make this control keyboard focusable. So now someone using a keyboard with or without a screen reader can actually reach this control and have some hope of using it. And tab index with a value of 0 just puts the element into the tab order based on the element's location in the DOM. So it's the best way to make something keyboard focusable in the most natural way from a user's point of view. We're going to add some focus styles, because when you hover over the button with a mouse, it changes to let you know that's where your focus is. We need to do the same thing when you move focus onto the button using a keyboard. And all we're doing is duplicating the CSS. So exactly the same styles are applied on blur or on focus, and everybody gets the same experience. We need to add in the keyboard behavior, because remember, the browser isn't going to do this for us. So we're already listening for click events. That's pretty much standard when you're creating a custom widget. But we need to also listen for keyboard events. And we're going to do that using the key down listener. We use key down because we need to listen for the space or enter keys being pressed. And key down is the thing that will listen for non-print characters. And it will return the key code of whichever key has been pressed. That lets us listen for either the space or enter key codes. And if any other key has been pressed, we can just let those keys go on and do what they're supposed to do. But if the space or enter keys are the ones being used to activate the button, then we can capture those key presses and from there execute the function that we want to get the widget to work. Back to the ARIA. We're going to use ARIA-expanded, and again, we set this on the button. What this does is tell a screen reader that when the attribute is set to false, that the widget is collapsed, it's closed. When you set it to true, that the widget is open and something has been displayed. And again, if you use this widget and you're cited, when you click the button, it's really obvious the content appears and you can see this. But as a screen reader user, as a blind person, you can't do that. So this attribute tells a screen reader user when the widget is open or closed. We're then going to associate the styles with the state of the expanded attribute. So using a CSS attribute selector, we're just going to say that when the expanded attribute is set to true and the widget is open, change the display CSS property, and similarly, when it's set to false, set it back to display none, so the content is hidden away. And this keeps the code really neat, but it also means that you've got a visual representation of the ARIA. So from a development point of view, keeping this relationship pretty tight like this means it's a lot easier to get the accessibility right, because if you change the accessibility, the styles maybe won't work or will work differently, and you can see that really quickly. We use the ARIA controls attribute, and again, this goes on the button, but we give it the ID reference of the div that contains the content. And this creates a relationship between the button and the content to be displayed. So now when the screen reader user clicks on the button or uses the enter key on the button, in some screen readers, for example in JAWS on Windows, there's a shortcut key that's available that lets you move focus from the button straight to the content that's just been displayed. In this case, where the content appears just below the button, that's not too big a thing. But if the button caused a change in the content somewhere else on the page, having that shortcut makes things a lot easier, because you don't know what's happening visually on the screen. So being able to jump to something new is a really good thing to be able to do. We're going to add ARIA hidden, and we're going to do that in two places. We've got ARIA hidden on a span that contains a little icon on the button. The icon isn't something that a screen reader needs to know about. It's just a visual representation of the state. And so we're going to use ARIA hidden. What this does when it's set to true is remove the element and all its content from the accessibility tree. So as far as the screen reader is concerned, this element doesn't exist. It's just not there at all. So we're going to use the same element attribute on the div that contains the content. In this case, we're going to change it. Initially, it'll be set to true when the widget is collapsed, because we don't want screen readers to be able to access that content until they've used the button. Soon as the button is used, then we change this attribute to false, and suddenly this content is now available in the accessibility tree again, and screen readers can access it. Again, we're going to associate the styles using the same technique, again, for exactly the same reasons and in exactly the same way, using an attribute selector to tie the visual representation of the widget to the state of the ARIA attributes. Last, we're going to add in the functionality. So in the script, we were listening for the key, strokes, space, or enter, or the click event. When that happens, all this script does is change the state of the ARIA expanded and ARIA hidden attributes. That then sets off the cascade that changes the visual style, causing the content to actually appear on screen. And hopefully, the widget works as we expect. So if I can flip over my audio again. What we should be able to hear now is the difference that all of this code has made to someone who uses a screen reader.
Page up. Tequila button collapsed. Tequila button expanded. Use JAWS key plus Alt plus M to move the controlled element. Move the controlled element. Makes me happy ...
So now there's a whole lot more information. So having started just hearing the word tequila, which is a good word to hear, we now have lots more information, that it's a button, so I know I can do something with it. If I do something with it, I'm told that the content has opened. I have a screen reader shortcut that lets me move to that content, and it gets read to me, which is exactly what we want to be able to do with this widget. So with just some changes to JavaScript and CSS and some ARIA, we've gone from having some content that only mouse users could use and enjoy to having something that now at least keyboard users and screen reader users can also use and enjoy. And that's really what accessibility is all about. It's taking small steps to do what we can to improve the way different people interact with the content and the products that we build.
Page down. Thank you. Question.
Thank you very much. Спасибо.
Ребят, вы можете задавать вопросы не только по-английски, но по-русски мы переведем. Вопросы?
Leonie, thanks for your amazing talk. It's very valuable for us. What I'm going to ask is a question that probably bothers everyone in this room. Well, in this fast-paced world of development, a significant, I guess, amount of applications are not developed with the focus on accessibility from the very beginning. So, may you please provide any clues or, recommendations on what tools or probably what approaches we can use to inspect our existing applications, existing interfaces, and know what should we focus first when adding accessibility to them. Thank you.
Sure. Tools, there are lots of tools. If you develop on a Mac and you use the Apple SDK and an Xcode coding environment, there is a tool called Accessibility Inspector, and that will let you look at your code, and it will tell you what information is being made available to screen readers. So like we saw earlier in my talk with the Windows example, you can get that same information, but for code on a Mac in Safari. If you use Windows, there are all sorts of tools. Firebug is a good tool. The Web Developer Toolbar for Firefox also has accessibility information. In Chrome, the Chrome Dev Tools and Chrome Accessibility Tools will do the same thing. There is also a tool freely available from the company I work for, TPG, called A-Viewer, and that lets you look at accessibility information in pretty much any Windows browser, which is quite useful. In terms of where you start and what you do first, whatever you can is the short answer. Don't wait for your managers to tell you something has to be accessible. The power is with you guys as developers. Change one little thing, maybe give some images, some alt text, maybe make sure that you can use the stuff you're building with the keyboard. Throw away your mouse for 10 minutes when you've just finished a sprint or a piece of coding, and just see if you can use it with the keyboard. If you can't, fix it and then ship it out for code review. So don't try and fix everything all at once. Just read some blogs, find out what people are talking about, and look for ways that you can maybe apply some of that advice as you go through in your job.
Oh, thanks.
Еще вопросы?
Спасибо за доклад. 3 коротких вопроса. Первый: сколько сайтов за рубежом, в Англии используют все это, чтобы...
How many websites in England use accessibility and are accessible?
Yes. In England, we have good accessibility. So the UK government website that I work on, when we started building that in 2011, we wrote 10 design principles, and they governed everything that we have built, and one of those was accessibility. For other websites, banking, grocery shopping, they're all pretty good. When you get to sites like Amazon, it's okay. Google search, it's okay. Google everything else, rubbish. Yandex, actually, I have to say, does some good stuff on accessibility. I had a chance to look at some of the services for that, and they're pretty good. But to the UK specifically, some stuff is really good, some stuff's okay. A lot of stuff is okay, and some is really bad.
Какие кнопки обычно на клавиатуре она использует при навигации? Стрелки и Enter или еще что-то?
Which keys do you use always? Is it arrows for navigation? Is it arrows or something else?
Yes, I use it. So screen readers have lots of shortcuts. You might have gathered that from some of the things I said. One shortcut lets you navigate between headings on a page, the H6, 5, 4, 3, 2, 1 elements. I use that a lot when I'm navigating web pages because it's a good way to get to a section of a page that I think is interesting. Landmarks are also another way I navigate web content. But from there, if I want to look at the details, yes, I'll use the arrow keys probably most often, tab quite a bit, and enter to do stuff, to interact with stuff.
И последний вопрос. Как озвучивает вот эта штука скрытие элементов? То есть там какая-то статья, и эта статья раз стала скрытой, он же не будет там всю статью перечитывать и сказать, ну, и говорить о том, что этот текст пропал.
How screen reader tells you that something disabled or disappeared?
So if you use the disabled attribute in HTML, my screen reader will just tell me button disabled. And then read the accessible name of the button. So if we disabled the disclosure button we were just looking at, it would say tequila button disabled. And so I would know I couldn't use it. When something has disappeared, you don't get told, usually. There are exceptions if you use an ARIA live region, which turns a piece of content on the page into something that will automatically get announced by the screen reader. There is a way to get a screen reader to tell you when something's been removed from that live region as well as added, but that's an exception. In terms of general kind of content removal, you don't get told about it.
Еще вопросы?
When you're reading the page, do you need to read all of content on the page, or you can understand which part is content on the page and navigate on content blocks or maybe paragraphs?
No, I don't listen to everything. You used to have to. 10, 15 years ago, screen readers didn't really understand HTML and all the roles and states and names very well. So you had to read a page from top to bottom, and it took forever. Now we have all these shortcuts because browsers understand HTML and make information about its accessibility available. So I can navigate by headings. I have shortcuts for navigating between tables, lists, images, graphics, paragraphs, divs, pretty much any kind of content. And with the landmark regions, as I said before, you've got another way of navigating, but when you navigate between landmarks, you also get to hear what the kind of area of the page is. You know, if it's a search or navigation or an article or the main content area. So all of these things are now much more commonly used and make things much better.
For example, we have two blocks. One block with content you need, it's maybe a post, and second block with advertising. How you do understand which block is needed for you?
My screen reader has a way of ignoring advertising in frames, which is awesome. But you could, I mean, if you use the main element to represent the main kind of the important content of the page, that's the best way to do that. With the advertising, what you could do is use the section element and use ARIA-label to give it an accessible name, perhaps of advertising or marketing or whatever word is appropriate to your particular audience. So when my screen reader gets to that section of the page, it would be told that this section of the page is to do with advertising or promotion of some kind.
The last question.
You don't have to tell them that screen reader users can't. Don't see these.
Hello, thank you for your talk. I have a question about dynamic sites. The sites that load content with Ajax without reloading full pages. How screen readers work with such pages? For example, if you go from the news read to the full news content without reloading pages, how did screen reader?
If you're just using Ajax on a static page, the screen readers are good at knowing when something's changed. So when the DOM changes, the browser fires an accessibility event, changes the accessibility tree, And that is then communicated to the screen reader that goes looking for the changes to tell the user about. If you're talking about single-page applications made with ARIA, Angular, or Ember, you have to work a bit harder to make things accessible. For example, when you load a new page into a browser, the page title changes and keyboard focus moves to the top of the page. If you have a single-page application and you're just rebuilding the view, that doesn't happen. So you have to use sort of manual techniques to recreate that same experience for screen reader users. There are some good articles on using Angular, Ember, and other frameworks that explain how you can do these things if you search for them.
Давайте скажем спасибо Леоне, она приехала к нам издалека. Давайте все вместе дружно поаплодируем.
Thank you.